but I'll be on it always, always and ever.
Hi, welcome back. So today we are going to learn how to identify whether or not our chemical equation is balanced or not. Now, before we get into actually doing some examples, I want to go ahead and write out a few notes so that you can keep in your arsenal as you are navigating how to identify whether your equation is balanced or not. So you know that a chemical equation is balanced. You know that it is balanced because, sorry, I'm just pausing so that you can have time to write. All right, so is it balanced? Okay, so you will know because for each, and this is for each element, all right, that's a part of your equation, the number of atoms on the reactant side must equal the number of atoms. Oops, that is not cute. Uh-oh. The number of atoms on the product side. Okay. So that basically just means that the number of atoms on your reactant side must equal the same amount on your product side. Okay. Now you're able to identify your number of atoms by your subscripts, by looking at your subscripts. Okay. So subscripts are going to be very important. Okay. This is how we identify our number of atoms. Okay. So this is some great notes to go ahead and keep in mind as we do some examples. Okay. Now, a tip. Let me get some tips here. All right. So tip number one. Okay. So when you want to identify whether or not your equation is balanced or not, one, you want to make a list. Okay. You want to go ahead and make a list of your elements. Under your yield sign. Now, I'm a big advocate for being able to see my work. If I can see my work, I can see what I'm doing, okay? So this will help, okay? And then tip two, okay? You're going to check to see if you have the same number of each element on both sides of the equation. So that means your reactant side. Why can't I spell? Reactant side and on your product side. They got to equal, baby. They have to equal. Okay? So you know that it is balanced if elements equal on both sides. This is very important. All right? So go ahead and get that written down. All right. So let's get into the fun part. The fun part is now determining, actually doing some examples to determine whether or not your equation is balanced, okay? So first up, we're going to have this example here. So we have Zn plus HCl yields ZnCl2 plus H2. All right. Now, if we look at our list or our tips, right? Our first tip is to make a list of each element under your yield sign. So what I like to do and what I like to show my students is to go ahead, make a line under your yield sign. So go ahead and separate your reactants from your products, okay? And so from there, I like to go ahead and create a list. So I'm separating my elements. I got Zn. I'm going to separate H from HCl, and I'm going to separate Cl from H, okay? So however I set up my list on my left side, I like to set it up the same way on my product side. And that's just simply because it just allows for me to look from left to right to see whether or not I have the same amount of each element on both sides. All right. So now that I've set up my list, okay, now I'm going to actually go through and look at the subscripts of each element from both sides to count up to see if I have the same amount. So I'm going to start with my reactant side because we read our equations from left to right. So I'm going to start with Zn on the reactant side, and I see that I only have one Zn present, okay? Then I'll look at the subscript on hydrogen, okay? And so your subscript is the number, all right, that is at the bottom of your element. And we know that if there is no subscript there, that means that it is 1. That there is no subscript next to that element, it means that it is 1, okay? So for hydrogen, we have 1 because there is no subscript there. And the same thing goes for Cl. Because there is no subscript there, we know that it is 1. All right? So now we're going to go to the product side. When I look at my subscript for Zn, there is no subscript there, so I know that it is 1. Okay? Now, I'm going to go to H. I'm just going to go in the order that I see that I have my list in. So when I go to H, I see that it has a subscript of 2. Okay, so because that 2 is there, I know that I have 2 hydrogens present. Okay, and then the same thing for Cl. It has a subscript of 2, so I know that on the product side, I have 2 chlorines present. Now, when I look at each side, I see that for my reactant side, I only have 1 Zn, and then for the product side, I only have 1 Zn. So yes, the Zns, they're good there. And then when I go to hydrogen, I see that I have 1 hydrogen on the reactant side, and then I have 2 on the product side. They are not the same, okay? And then the same thing for Cl. I have 1 on the reactant side, and then 2 on the product side. They are not the same. So that makes this equation unbalanced. Okay? It is unbalanced. In order for this to have been balanced, both elements on both sides needed to be the exact same number. And in this case, it is not. So therefore, it makes this equation unbalanced. Okay? So let's do another example. All right. So I have FeS plus HCl yields H2S plus FeCl2. Okay. So what I'm going to go ahead and do, I'm going to go ahead and create a line under my yield sign to separate my reactants from my products. Okay? So when I separate my reactants from my products, I'm going to go ahead and make a list. When I make a list, I'm going to separate my elements. I got Fe, I have S, I have H, and I have Cl. Okay? So you have to separate each element to its own individual element, okay? Away from its compound. I'm going to do the same thing. The way that I wrote my list on my reactant side, I'm going to write it in the same order on my product side, only because I don't want to be looking all over the place. I want to be able to look from left to right to see if my elements match. Now that I've done that, I'm going to go ahead and look at my subscripts for each element. Okay, so I'm going to start from my reactant side. I see that for Fe, I only have 1 Fe present. I have 1 S present. I go to H, I have one H present, and then I have one Cl present. As you can see on the reactant side, there are no subscripts, which means that it is one of each element present, okay? Now I'm going to go over to the product side. When I go over to Fe, I see that I have one Fe present. For S, I have one S present. For H, I have two hydrogens present. And for Cl, I have two Cls present. Now, when I go through my list to just check to see if they match, I have one Fe on both sides. They're matched. They're good. For sulfur, I have one of each. They match. They're good. Then I get to hydrogen. I have one on the reactant side, but two on the product side. They do not match. When I go to chlorine, I have one chlorine, and then I have two chlorines on the product side. They do not match. So since all of my elements do not match, it makes this equation unbalanced. All right? It is unbalanced. I hope this makes sense. All right. And now we're going to do our final example. The final example, we have 2H2O plus O2 yields 2H2O. Now here, I really want you to kind of pay attention to what's getting ready to happen. Now, based off of what we've learned so far, we haven't learned anything about these big numbers that's in front of this equation, okay? So since we haven't learned anything about these big numbers that's in front of the equation, we're going to just do what we've already learned, okay? And what we've already learned so far is that first, we're going to start with writing our line under the yield sign to separate our reactants from our products. And so since we're separating our reactants from our products, we're going to go ahead and make out a list, all right? So when we make out our list, on our reactant side, we have hydrogen and we have oxygen, okay? Hydrogen and oxygen. And then on our product side, we have the same, hydrogen and oxygen. Uh-oh, I made a mistake here with this example. Actually, let's scratch this. Let me rewrite this example over. This example should be 2H2 plus O2 yields 2H2O. Sorry about that. So let me just go ahead and just start from here. So it should just be H and O. H and O. Now, based off of what we've done so far, we know that we got to look at our subscripts, okay, in order to get the number of each element of our atom. So on the reactant side for hydrogen, we have two hydrogens. And then for oxygen, we have two oxygens on the reactant side. And then when we go to the product side, we have two hydrogens, and then we only have one oxygen. Now, when we go through, we look to see that our hydrogens, they match. But when we get to our oxygens, they do not match, which, based off of what we've learned so far, will make the equation unbalanced. However, okay, you see these big numbers that's in front of the elements, those are what we call coefficients. And that is what we're going to get into in our next video of doing examples of how to use coefficients to actually balance our equation. So to go ahead and close this out really quickly, I'm going to show you how using these coefficients helps us to balance our equation. So as you can see, we already have it set up to before using or considering the coefficients, our equation was unbalanced. Now, when it comes to coefficients, you use coefficients because in order to balance your equation, you cannot change your subscripts. If you change your subscripts, that means that you actually are changing your element. Okay? So, when you use a coefficient, you will use a number between 1 and infinity that you can use distributive property for in order to multiply by your subscript in order to get your equation balanced. So here, for instance, let's use this for an example. We have the coefficient 2, but when we multiply 2 times 2, the subscript 2, we now have 4 hydrogens on the reactant side. Now, we've also learned that when there is no 1. Well, there is no coefficient here, okay? There's no coefficient here, but since there's no coefficient, we know that that is 1, okay? When there is no coefficient, it just means that it's 1. So now we're going to take that coefficient and multiply it by its subscript, which 1 times 2 is 2. So we know that now with that coefficient, we still have 2 oxygens on the reactant side. Now we're going to go to the product side. And when we go to the product side, we're going to do the same thing. So 2 times 2 is 4. Now we have 4 hydrogens on the product side. Then you're going to do the same thing. Okay, you're going to take that 2 and multiply it by that subscript by oxygen, which there is no subscript there, which means that it's just 1. So 2 times 1 is 2. So now we have 2 hydrogens on the product side. Okay, so this is us using distributive property with the coefficients in order to get our equation balanced. And as you can see, when we go back through, on the reactant side, you have 4 hydrogens. On the product side, you have 4 hydrogens. On the reactant side, you have 2 oxygens. On the product side, you have 2 oxygens. So now that makes our equation balanced. All right. See you in the next video.
Don't play with it, don't be dishonest.